We'll wait for 1 to 2 minutes and then I'll start. Samarth, are you there? Samarth Jain.
Yes, ma'am, I'm there.
Okay, just let me know this screen is visible and voice is audible.
Yes, ma'am, it's
Yes,
audible.
ma'am.
Okay, okay, done. So in the last class, we discussed about the introduction of CMM, the working principle of CMM, the different component which we have in CMM, and the important features of coordinate measuring machine. Okay, and we talked about the probe and the various advantages of the coordinate measuring machine. And today I will cover the types of CMM. So I think all have been joined this class. Should I start the class?
Yes, ma'am.
Okay. Okay, so as far as concern of the types of CMM, we have the different type of CMM with their unique features. Okay, some of the are given over here, some maybe not given over here. Okay, but we have the n number types of CMM. In this class, I'm going to tell you the major uh, types which we generally used as a coordinate measuring machine. So you can see there are the four machines are given over here. Okay, these are the prototypes you can see. One, we have the bridge type machine, then we have the column type machine, then we have the gantry type machine, and then we have the horizontal arm machine. They all have their specific features they used for these specific applications. We will discuss one by one. Okay, so first we will talk about the bridge type structure. Earlier also I have told you the working of CMM, which was the bridge type structure. You can see this was that, this one. This is also the bridge type structure. So if I'm saying bridge type structure, that means you can see from the diagram, we have the workstation that is showing the XYZ direction. And then we have the top body, which is looks like a bridge. That is why it is called the bridge type structure. Okay, so in this bridge arrangement over the table, it carries the quill along the X direction. You can see we have the probe holder over here. Okay, in this we can attach the probe. In this particular diagram you cannot see the computer or the system. This is generally a structure which showing the bridge type CMM, but also the computer is also attached with this. In general, it is sometimes referred as a traveling bridge. So you can see over this bridge, this probe can be travel from this side to that side. Okay, so it is very easy to measure all the cloud points throughout the workpiece. It is claimed that the bridge construction provide better accuracy, although it may be offset by difficulty in making two members having perfect alignment. So sometime what happen, the trimming problem can be occur, means the parallel adjustment, because there is no scale or the measurement site over here and there. So when you place the workpiece in this particular zone or the workspace, it is difficult to manage whether it is at origin point or whether it is aligned with the sides of the workstation. So we have to be very careful about that. And if it is done, then it is very easy to manage the bridge type of structure, and it is very easy to collect the all cloud point throughout the workstation, or throughout the workpiece. Okay, so this is by far the most popular CMM construction. So you have to understand one thing. In the previous class, we discussed about the different component of the CMM. So obviously, whenever you are talk about the bridge type, gantry or column, everything will remain same. Means there will be one probe, there will be one control system, there will be one bench wise, or you can say the workstation, there will be XYZ direction. Means these things are certainly common, but the alignment of the probe can be different, maybe the size of the workstation can be different, maybe the precision value can be different, how you are measuring the workstation, that can be different. Okay, so this is about the bridge type structure. Now the second one is the cantilever type. Now you can see from the diagram the probe alignment, means how we can place the probe, that is about the cantilever type. I hope you heard about the cantilever beam. Okay, so one end is fixed and one end is in hanging position. So similarly, you can see the probe over here. Okay, so that you can see, this is how the probe is attached with the system in the cantilever type position. That is why it is called the cantilever type coordinate measuring machine. So you can see XYZ direction are over here. The minus point is that in this, although this cantilever is fixed, so it is very difficult to use the larger size of the component, because you can see there is a workstation which has a limited parameters, because the cantilever is not movable. Probe is not in movable condition. That is why this size of the workstation is small comparatively others, like gantry and the bridge one. Okay, so it is typically limited to small and medium sized machine because of the small floor space requirement. Parts larger than the machine table can be inserted into the open side without inhibiting full machine travel. So you can use some kind of excess material if you have, but you have to be very careful that the sides of the machines should have certain kind of a space, that that particular part can be manageable in that particular domain. Okay, so this is about the cantilever type of coordinate measuring machine. So if you will compare cantilever with the bridge, so bridge can be occupy the larger size of the component, and cantilever is specifically for the small and the medium sized machine. The next one is the column type. So you can see here the placement of the probe is in column type direction. Okay, or the I think in the buildings you have seen the presence of column. So similarly like that, the column type machine is commonly referred to as a universal measuring machine rather than the CMM. So in the industry language, generally it is preferred as the universal measuring machine. Okay, not universal testing machine. That is different thing. So these machines are usually considered gauge room instrument rather than the production floor machine. Because of their size and because of their specific conditions, they are generally tabletop type of machines which require the less space. Okay, but if you will compare it with the other type of CMM, then those are placed at the production flow machine. Okay, so this is one of the difference. The direction of the movement of the arm are shown in figure 8. So movement will be in the X, Y and Z direction. So this will be the Z direction. Sorry, this will be the Z direction, and the other two are X and Y direction. The constructional difference in column type with the cantilever type is with X and Y axis movement. So the difference between the column and the cantilever, you can see here is X and Y direction are different. The placement of the column is different in comparison of the cantilever. So this is the cantilever and this one is the column. Okay, so the placement of the probe can be different in both these situations, but they both are used for the small component, small size of the component. Next is the gantry type. So as you can see from the diagram, you can see there are the two types of bridges. In between of these, we have a crane type of a structure, and over that the probe is hanging. Okay, and you can see the size of this bridge type of a structure, or the you can see it is very large. And as per the requirement, you can also make, or you can also customize this particular size. So the gantry type of CMM is very much useful for the large type of components. It allows the operator to remain close to the area of inspection. Means you can easily place the component in between, okay, and then you can easily place the probe throughout the component, and you can easily collect the data. The movement of the X, Y, and Z axes are also shown in figure. So you can see the component can be moved in X and Y direction, and the probe can be moved in Z direction as well as X and Y direction. So it is very easy to manage the probe throughout the component. Okay, so in this gantry type arrangement, you can see the arm are held by the two fixed support. Okay, so this arm is held by these two supports, which you can see fixed but large in shape. Okay, so it is very easily manageable for the large component if you are using the gantry type of coordinate measuring machine. If you will compare in terms of the bridge type and gantry type, then gantry type CMM provide you the more large component cloud points in comparison of the bridge type. So if somebody will ask you which type of CMM you will use for the large component, then I think you have to give the answer that is the gantry type. Okay, because they are asking in terms of the relativeness. They are not asking ki large component when you can use, or when you can use by the using bridge type or gantry type. Obviously if you will compare in these two, you will give the answer that is the gantry type, but bridge type is also used for the large component. The next one is the horizontal arm, or the horizontal type coordinate measuring machine. So you can see if you're talking about horizontal arm, so there is one arm like structure. So this particular arm can be moved upward, downward, above and the behind and throughout, and it also work like a spindle. So you can easily measure the all the cloud points throughout the component. The open structure of this arrangement provide optimum accessibility for large objects such as dies, mold, and car bodies. So you can do one thing, you can keep your car body over here on the platform. Okay, you can see the platform above here, and then you can easily measure the cloud points by moving this horizontal arm. Okay, so some horizontal arm machine are referred to as layout machine. There are some horizontal machines where the probe arm can rotate like a spindle. I already told you, either you can keep it rectangular arm, or you can also make it like a spindle type structure so that you can easily rotate it to perform the tramming operation. Operation means if you want to align the axis, if you want to see the whether this particular component is in aligned with the XYZ direction properly or not. Okay, so alignment part can be shown by this particular horizontal type of arm. Okay, so tramming refers to the accurate mechanical adjustment of instrument or machine will help to tram. It should not be like if your arm is not aligned properly, it will not give you the correct cloud points. So you have to be very much sure whenever you are using any machine, not only the CMM, any machine, you have to be firstly concerned about the calibration of that machine. Means that machine should be so much appropriate that it can give you the correct value of whatever the parameter you are taking. Okay, so this is the horizontal type of machine. So majorly we have covered the bridge type, cantilever type, horizontal arm, column type, and the gantry one. So these five we have taken in this particular topic. But other than this, I think one or two CMM also there in the market. Okay, but majorly these CMMs are used, okay, in the industry perspective. Now you can see the various applications of the coordinate measuring machine. So you can use it for the metrology domain, or the inspection domain, or maybe you can use in the different type of measurement thing, like either you can use the linear measurement or you can use the angular measurement. You can collect the different profiles, you can collect the different geometrical features, or ultimately you can collect the cloud points of any component, which we basically uh, thought of in terms of the reverse engineering. So we generally use the CMM in the reverse engineering to collect the cloud points, either through the contact one or the non-contact one. So you can see there are the two mode of inspection operation. One is the manual, another one is the automated. Okay, so directly controlled unit means, automated means there is no need of manual intervention. That means you directly place the component to whom you want to collect the cloud point. You just on the machine, they will calibrate all the features, they will tram the specific xyz direction, and then they will start the collecting the cloud points. In manual, maybe sometime you have required the manual intervention to maybe set up the workstation, to set up the workflow in respect of the component to whom you want to check the cloud points. Okay, or maybe in between you want to change the position of the component. For that, you can use the manual intervention if you want, if you have the such kind of device that is not fully automated. The purpose of inspection is first piece approval, the process control, pre-assembly qualification of parts, and the reverse engineering. So this particular CMM is not only used for the reverse engineering perspective, it is also, or it can be also used for the inspection purposes, or the first piece approval means you have prepared a component, the first piece of the product, you just checked it through the CMM whether it is accurate or not, and then you can, when it got passed, then you can go for the other pieces manufacturing. Okay, so you can also go for the pre-assembly qualification of parts, means you can dissect the different component of the parts, and individually you can check the all part of the component, and then you can see whether these part are all qualified for this particular single component or not. If it is, then you can go ahead. If it is not, then you have to improve it. Okay, so there are a lot of purpose of the CMM other than using in the reverse engineering, or other than using or collecting the cloud points only. Okay, so this is how you can define the coordinate measuring machine. You understand the working of the CMM. Okay, you know the features of CMM. We were talked about the principle as well as the component of CMM. We know the advantage of CMM. Okay, and now we also aware about the different types of CMM. Okay, so this is all for today class. Okay. So in the next class, we will cover the data accumulation and the data retrieval. These two are the important parameters if you are working in the reverse engineering domain. I think you all have been heard about the data retrieval and the data accumulation. So in detail, we will cover it in the next class. And one more topic that we will cover later, that is the errors in measurement. So there are n numbers of errors. Okay, so these are the topics which we are going to cover in further class. Okay, so today I have to only cover the types of CMM. So in this particular class, if you have any query or any doubt, you can ask. If anyone have anything they want to ask regarding the topic, they can clarify it. Say yes or no. Are you all,
No, ma'am, no
or
such
you are
doubts.
only doing puja, Vasanta Panchami puja, which going to be started at 12? Huh? Prince, are you smiling? Huh? Because I also got the invitation from Yuva. कौन है युवा सोसाइटी का नेता? मेंबर सॉरी, कौन है?
मैम मैं हूँ मेंबर, अभी बस जाना है क्लास के बाद।
अच्छा, तो इट वाज आई थिंक स्टार्टेड फ्रॉम 12 ना?
मैम यस, मैं 12:30 तक मतलब पहुंच जाऊंगी।
अच्छा ठीक है।